Welcome, ladies and gentlemen. Shut up. Hello. Hi there. Let's turn off the music. Oop, wrong button. There we go. Welcome back for yet another episode of whatever we call this thing. Today we're going to be dealing with, I'm going to put that down, today we're going to be dealing with arrays and maps. So last week we talked about array lists, and we said that an array list was a collection of objects of the same type, which was, if you remember, it was ordered, indexed, and variable length. So you had a bunch of objects. They had fixed indices, so they were number 0, 1, 2, 3, 4, and it was variable length. You could add or remove things to them. Okay, so what we're going to look at today is what's called an array, which is different from an array list. I'm going to call array lists, just generally call them lists. An array list is one kind of list, but all lists work in the same sort of way. So an array is different to a list, or different to an array list. The important difference is that while an array is also ordered and also indexed, an array is fixed length. And so when you create an array, you say how big it's going to be, and then you put things in it. And it is always that size. So as a comparison, like we said, arrays are fixed size, whereas array lists are variable size. Arrays are actually built into Java, where if you remember, array lists are part of the class library. So array lists are not fundamental to Java. They're something that's been built on, that's been added in the library, whereas arrays are actually fundamental parts of Java, built into the language. And arrays can contain primitive types or objects, whereas remember that array lists can only contain objects. So arrays are kind of more limited in scope than what array lists can do, because arrays are actually a more fundamental data type. And in fact, if you go and poke around in the array list class, you'll find that internally array list is implemented in terms of arrays. So they hide all that detail from you, so you don't have to worry about what arrays are going on in there. But the array list has actually got arrays in there. So arrays are a more like a more concrete data type. Array lists are actually an object that internally use arrays. So fundamentally, a lot of things look, well, actually not the same. Arrays are a bit weird, I've got to admit. Arrays, one of the problems with Java is that arrays kind of sit somewhere in between the primitive types, which are very simple, and the object types, which have a consistent way of doing it. Arrays have this sort of, it's a bit of a mess. Personally, I think Java should have cleaned this up and made arrays look more like objects. But anyway, so arrays have their own special syntax, which you're going to have to get used to. And I'm going to remind you that you're not here to chat, so shut up. Good. So we want to declare a variable that is an array. The way it looks is like this. We have the item class, so the things that are in the array are of type string. Then we have this square bracket thing. 2 square brackets with nothing in them means that this is an array of strings. So if we left out the square brackets, that would just be a variable declared that was a string. But now we're declaring it as an array of strings. So the square brackets mean this is an array of strings. Similarly, we can have an array of ints. So it's perfectly fine to have an array of primitive values. And we can have an array of any object type we want. So if we have a book class, we can have an array of books. We can have an array of cars. We can have an array of anything we want to create. So this is declaring the variable. And so we have a variable, but obviously whenever we declare a variable, we've actually got to give it a value. So to create a new array, we use the new operator like we've encountered before for objects, but again the syntax is a little bit weird. So arrays are always this special case that's a bit different to everything else. So we have a variable called class role, which we're going to store a list of strings, which are going to be people in the class. And so we say new string, and then in square brackets 3, or however many things we want to have in that array. So if we have a 3 in there, then what we create is this lovely, lovely array over here with 3 entries on it. And those 3 entries are initialized to null. So like when you create a new variable, it gives them initial value. If you create an object variable, the initial value is always going to be null. If you create an int variable, the initial value is going to be 0. Well, in this case, it actually creates 3 new variables inside the array and initializes all 3 of them. So if you initialize, so if I create a new array like that, and the things in the array are objects, and so I've initialized all 3 of them to null. If they were ints, all 3 of them would be 0. If they were booleans, I think all 3 of them would be false, but that seems likely, but don't bet on that, go and check. But they all basically are initialized to some standard value. So the idea basically of an array is that it's a way of creating a large number of variables in one hit, and giving them, rather than giving them all individual names, you're giving them just one name and an index from that name. So this really is just like we created 3 separate variables, except rather than giving them 3 separate names, they're just addressed by the name class role. And so the way we look at a variable in an array, so before we get there, of course we don't have to say a specific number. Sometimes we want to create an array of whatever size we've actually computed. So rather than saying an array of 3 things, we can do some code. This is just me making stuff up, but maybe some code here to get the number of students in this class, and then to make the class role, I take that number. I make an array of that number of students. So the value in the square brackets can be any expression we want that computes an integer. So we can do a calculation in there, we can use variables, we can use functions, we can use anything we want that will give us an integer that we can make as the size. Now, that said, we can't have a negative sized array. So if you have the number -3 in there, Java won't like you. You can have a 0 sized array, actually, if you want. You can create an array with 0 things on it if there's any reason for it. Of course, an array with 0 things in it will always have 0 things in it because they're fixed size, so it's kind of a pointless thing to have. But sometimes you will actually, if there are no students in the class, then the right thing to do is to create an array of 0 items. If there are 500 students in the class, then we create an array of 500 items and whatever. So we don't have to specify the number in advance. We can calculate the number and use the results of that calculation to create the array. But we're going to persist with the idea that we just had 3. So then we can use the entries of that array as variables. And the way that we do that is use the name of the array, class role, and then again in square brackets after that, the index of the item that we want to access. And so if we want to access, so we can treat this like a normal variable. We can read it and write it in the same way we would any other string variable. So we could store the value Malcolm in class role 0, and this variable would now have the string Malcolm in it. We can store the value Sim in class role 1, and this variable now has that. We could read the value from 0 and store it into 2, and so it takes this value Malcolm and copies it into there. So they're really just like any other variables that we'd be dealing with, only we have this special way of naming them, which is by their index rather than giving everyone an individual name. And once again, as computer scientists, we always count from 0. So the topmost element in the array is element 0. If in this array has 3 things in it, they're numbered 0, 1, 2. Again, this number in brackets doesn't have to just be a number. It could be anything that calculates an appropriate index. So we could use a variable in there to get at. If we had the variable I, which was equal to 3, we could get at element 3 by saying class role I. We'll see more examples of that in a little while. So we can read and write elements, and unlike the array list where we were actually adding elements to the list, so as we added things, more things got on there. This time we're actually overriding whatever value's there. So if I was now to assign a new value to class role 0, it would overwrite this one, and I can never add more things to the array. There's no way. Now that I've created an array of things, it's always going to be an array of 3 things. some of those things might have null values, but there's still a variable there. So we can actually also ask for the length of an array, which seems a bit pointless if we knew we created an array of length 3. But it's possible that that we got this array from somewhere else. Another part of the program sent us this array. We don't know how long it is because we didn't create it, and so we can actually ask for the length, and we say class role dot length. So it's like accessing a field or a method on an object. Use the same dot operator. Unfortunately, it's not. It's again, arrays are a little bit different. It's not. While it is like a field, it's read only. So we can read. We can get the class role dot length and assign it to a variable, and it'll find out the length is 3, and so it'll assign 3 to that variable. But we can't write to it, so we can't say class role dot length equals 4. It'd be nice if you could do that, an automatic way of resizing the thing, but we can't do that. So you're not allowed to write to the length. You can only read it because this is a fixed size array. Right. So like array lists, we talked last week about how you could iterate over an array list using the for each loop. You can't iterate over an array using the for each loop, right? For each loop only works on certain collections, and the array isn't one of them. So this won't work. So don't try doing that. But what we commonly do then is use an ordinary for loop to iterate, to count through the elements and do some operation on them. So if we have a for loop like this, we start at 0, we keep going until as long as we're less than the length, and every time we go around we increment. And I don't know if I've actually told you about this one, but this is add 1 to I, and so it's a shorthand for saying I equals I plus 1. So every time we do this, this basically starts at 0, and then if we have an array of 3 things, it starts at 0, then does 1, then does 2, and when it hits 3 it ends. So we could use this to do some operation on everything in the class role, and I'll show you an example of that now. So while we look, yeah, I'll mention that in a bit. Let's come up with a new project. Okay, let's create a new class. We'll call it role something here, and so now I'm just going to let's do this private string array. So it's an array of strings, my class role, and we'll make a constructor public role. Actually, yeah, whatever. And we'll say this is going to be. Actually, we'll get an argument here. So we'll say this is int number of students. So we'll actually ask for how many students we're going to have, and we're going to create an array of that size. So now my class role equals new string square brackets number of students. Okay, so first of all, let's have a look at that. Let's compile that. No syntax errors, that's good. And now we'll create a role. So new role. We'll have a role of 10 students. Okay. And now if we inspect this, okay, so what we see here is the array that we've just created. And if we double click on the array, we can see there's the array of things we created. And so that array has length 10, and it has 10 entries numbered from 0 to 9. So that's what we expected, right? Now, so we'll close that. Let's how are we going to set public void? Actually, yeah. Set entry, set name, int index string name. Okay, so what this method is going to do is set the name at number I, and if you shut up over that side, Yes, you guys looking over there. Hi. Shut up. And the guys behind you, shut up. Thank you. So we have, what we want to do is we're given an index and a name, and we want to store that in our role at the appropriate index. So we're going to say my class role index equals name. So we can use the variable index that we've got to find the appropriate entry, and then we can assign the value name into that entry. And so now if we do that, and hopefully we can compile that, then we create a new role of, let's just create a role of 5 things, and we look at our role, and it's all nicely, there it is, there it is. So they're all initialized to null. But now if we actually take that role and say set name, and let's set name number 3 to Malcolm, just for the hell of it. Okay, and now if we come over and look at our array, name number 3 is now Malcolm. Right. So basically we can, whoops, that's not what I intended to do. Where is that? No, not that. Come here. One of these buttons. No, it's gone. And it won't come back. That's lovely. Come back, Blue Jay, all is forgiven. Oh, there we go. Okay. So all we did there was just use the index to look up an entry in that array, and then assign a value to that. Okay, so let's now print out the role. Public void print role, and we'll print out every entry on there. So in order to print every entry on the role, we do a for loop. We have an index variable which we're going to call I. It's generally all right. Well, I encourage you to have good names for your variables. If it's just an index, something that's doesn't really have a very important meaning, calling your index variable I or something like that is all right, because you don't really need to call this index. It's fairly standard to call an index I if it's just counting through a counter like this, counting through a loop. So it's going to start at 0. We're going to keep going as long as I is less than the number of things on the roll. So it's less than my class role.length. And every time we go around the loop, we're going to add 1 to I. And so there's our for loop. And you're going to write a lot of for loops that look like that in your time. They're almost always going to start at 0. They're going to finish at the length of some object that you're checking at, and they're going to, every time around, going to increment by 1. So really, you almost never write any other kind of for loop. So every for loop basically says count from some starting value up until you get to some finishing value, and every time you add 1 as you go around. So it's just do this. Essentially, this says do this as many times as there are items in the list. And then what we can do is say system.out.println, and then we can say my class role I. So we can use that index variable, that counter that we've got here, and because it starts at 0, so the first time around this loop it's going to print out my class role 0, and then it's going to go up to 1, and it's going to print my class role 1, and so forth, and it should print the entire role. Let's see that in action. Compile. Okay, so we have to create a new role. We're going to have 5 people on our role, and if we print this role at the moment, what we get is 5 nulls. So because those entries are all null, if you print a null, you get null, right? So which is interesting because it doesn't one of the important things is it doesn't initialize strings to the empty string. You'd think that the initial value would be a string that doesn't say anything, but it isn't. The empty value is null, which means there is no string here at all. There's actually an important difference between the string that is the null string, which is no object at all, and the empty string, which is the string that has nothing in it. So in fact, we could create a new entry, entry number 0. We could make entry number 0 that's just 2 double quotes next to each other. That represents the empty string. So everything in between the quotes is what's in the string. Because there's nothing between the quotes, it means there's nothing in the string. So this is a string that has nothing in it. Now there's a difference between the string that has nothing in it and the null, which is not a string at all. So if we do that, now if we print our role, you'll see that the first entry on the roll is nothing at all. There's no string there. The second entry is null, the third one is null. Right? Okay, so anyway, let's go and create more entries. Let's put something, actually let's put a better value there. So let's say set name 0 to Malcolm. And let's set another name. Let's set name 5 to Morgan. Just picking random. Okay, so there's an interesting thing. When I created the role, I created it with 5 entries on it, and I just tried to set entry 5 to something, and what it gave me was an error. It says Java lang array index out of bounds exception, which basically means that this index was outside of the correct bounds. The correct bounds was 0 to 4. I tried writing a value greater than 4, and so it's given me an error. It said that this value 5 is out of the bounds. The bounds should be 0 to 4. The same error will happen if I try to write entry -1, which we can see. Oh, and we've got the same, even shows you here where the error occurred. The error occurred in that particular line of my code. So same thing would happen if I tried to do this. If I tried to say set name at -3 to Morgan. Again, it'll give me an error saying out of bounds. So I can only address elements 0 through 4. What I can do though, if I go to my code, let's put a name in a decent spot. Let's put Morgan's name at element 4. Okay. So now if we go to the code and let's set a breakpoint here on our print roll. Let's put a breakpoint there. And now if we run print roll, up comes the debugger. We stopped at that breakpoint, and you can see over here. So here's the class roll, which we can inspect, and that is what we expect, what we want it to be. We've set Malcolm at 0 and Morgan at 4. Make that go away. Close. Also down here in the local variables, you can see that index variable I've created has been made, and it starts out at 0. If we step through, first time it prints out element 0, and it goes back around again, and now I is 1, and so we step over, and now it prints the element at 1, which is null, and it goes around again, and now I is 2, and it prints out that element, and now I is 3, and it prints out that element, now I is 4, and it prints out that element. Now I is 5. It doesn't actually show that, but I does actually go up to 5. And as soon as I is 5, this test is no longer true, because 5 is not less than 5. So it stops. And so as soon as it's done, as soon as this test becomes false, it stops going around the loop. Okay, so I mean, this is a really easy way to count through elements, and you write code like that an awful lot. I'm going to close. Oh damn! It's going to complain to me when I do that. Debugger terminate. Aha. There we go. Okay. So that's how you use a for loop to do some operation on an array. And if you have arrays, you often want to do this. You want to do the same operation on every element of the array. So this is a pretty typical way of doing that. Actually, I'm going to show you one more thing, because I haven't really given you a good example of a while loop yet. So it's not in the notes, but here let's do something interesting. Let's say public void add name. And what we're going to do, we're going to look for the first entry, empty entry, and write the name there. Return false if there are no empty entries. All right. So what we're going to do is have a boolean there. So what we want to do now is we have this array. Some of the entries are null. Some of them have values in them. We want to write a name into the array, but we don't want to overwrite an existing entry. We just want to overwrite a null. So what we're going to do is look through the array and try to find that null. I'm going to draw this on the board. I'm going to have to use the that screen though, so let's put that, turn that screen off, or maybe not. Put that screen up, that should do the trick. Where's my pins? Oh, here they are. So what we've got, I'm just going to draw it here. This is a whiteboard, yes, good. Okay, so we have an array. It has 0, 1, 2, 3, 4 entries. This one's going to be, say we've already set that one to Malcolm. This one might already be Morgan. But this one's null, and this one's null, and this one's null. Okay? And so now we want to add the name sim. So we've got the variable, whoops, we've got the parameter name, which contains sim, and what we want to do is find the first spot in this array where we've got a null and write sim into there. Okay. So what we need to do is the problem is we can't just look at the array and say, okay, there's the empty spot. We need to actually go through the array from the top and find the right spot to do it. So the way we do this is write a loop which starts here and says, okay, let's look at entry 0. Is entry 0 null? No, it isn't, so we'll keep going. Let's look at entry 1. Is entry 1 null? No, it isn't, so we'll keep going. Let's look at entry 2. Is entry 2 null? Yes, it's null, so we can stop at that point and write it in there. So we need some way of scanning down the list to see where we're going to, when we've got the first null entry. If we get all the way to the end of the list, we want to say we can't do this. We want to say false. We can't write it because there aren't any empty spaces on there. Okay, so my laptop's gone to sleep. So the way we're going to do that is we're going to use a loop. We're actually going to use a while loop. So what we're going to do is say we'll have an index, so int I, and we'll start that value at 0. So this is the index of the entry that we're currently looking at. And now what we want to say is while while my class role, let's first of all say I has got to be, if I is, so this loop will only work as long as I is less than the length of the role. So if we say, so first of all, while it's less than my class role dot length, right? Okay. So we're going to loop around looking at every element until we've reached my class role length. We're going to add an incrementer there. So that loop on its own, that loop's equivalent to the for loop that we had before. It starts at position 0. It keeps going until we hit the class role length, and every time it goes around the loop, it adds 1. So this really is exactly the same as the for loop we were using above. But what we want to do now is we also want to stop. We want to stop if we hit the length of the list. We also want to stop if we find an empty entry. So we're going to say, as long as my class role, as long as I is less than length and my class role I does not equal null. So this now is slightly different. This says, so we have, every time we go around the loop, first of all we test that the index is less than the length of the list, which is true. Then we test whether the entry at that point is equal to null. And actually, if the entry is not equal to null, we keep going around the loop until we find a new entry. If the entry is equal to null, this is an AND statement. So I haven't actually really, I don't think we've really dealt with these yet. But this is a Boolean expression. So it's like you have integer expressions to calculate integer values. This is a Boolean expression. It says, is this true and that true? So a Boolean expression, the AND expression, is only true if both parts are true. So this is saying, is I less than the index, less than the length, and is the entry at that current spot not equal to null? If either of those things is false, then this test fails. So this will go around this loop until one of those two tests fails. Either we get to the end of the list or we find a null entry. If we've got to that point, one of those points, then we know we've finished that loop. Now we need to know which way did we finish. Did we finish because we ran out of entries, or did we finish because we found the right thing, found a spot? So we can say if I equals my class role, list.length. Okay. So this is where we ran out of entries. And so we returned false because we haven't found what we were looking for. We haven't found an empty spot. We got all the way to the end of the list. I went from 0, 1, 2, 3, 4 and then went to 5. 5 was not less than 5, and so the end list finished. So we said if I is 5 is the same as the length of the list, we've gone all the way through the list, and so we've run out of spots. Otherwise, we have a spot, so we can say this is where we found a null spot. So we write the name there. So this is where we go my class role I equals name. And when we found a spot successfully, we can return true, saying yes, we succeeded. So this is a little bit more complicated than anything I've shown you so far. What we're doing now is actually using these structures we've got a fairly complicated piece of data. We've got places where it's null and places where it's not null. We're looping through it, trying to find an entry that is null, and then as soon as we either find an entry, in which case we write the name in that entry, or else we get to the end of the list, in which case we return false and say we couldn't do it. So this is sort of a slightly more sophisticated thing, and we can see this in action. Let's compile this to make sure it works. Yes, we'll put a breakpoint in there. We'll close that up. We'll create a new role. Role 1. Oops, we need to say how many things are on it. We'll say there's 5. And we can now, so if we just add a name to an empty role, we'll add the name Malcolm. So okay, we start here. We create a new variable I, which is 0. So over here we can see that I is 0. I've done something wrong. Oh, all right. Okay. So no, it was right. It did this test, but it skipped right over it. But it did the test. It said 0 is less than 5, so that's true. But it also said, does my class role 0 equal null? My class role 0 is equal to null, and so this not equals, this exclamation mark means not equals. That was false. So this whole condition, true and false, is false. And so this whole condition failed. It skipped the loop completely and jumped to here. It now does that test. So where did the debugger go? It says, okay, I is currently 0. The length of the list is 5. So that test fails. So we do the else part. I is now 0. We're writing the name into entry 0, which we've done successfully. And so there we go, we've written the name into entry 0. And now we can just return true and say all's happy in the world, we've finished what we want to do. So now let's do that again. Let's write another name in there. Let's add the name Claude. Okay, so it starts at 0. It tests, is 0 less than the length? Yes, 0 is less than length. Is class role 0 null? No, class role 0 isn't null. Oh, sorry, yeah, no, class role 0 isn't null. So this not equals to statement is true. This is Malcolm, this is null. Malcolm does not equal null. So that's true. And so as long as that's true, it keeps doing the thing in the loop. And so it increments the value. And so it runs that statement, and I is now 1. It goes back and checks, is 1 less than 5? Yes. Is class role 1 not equal to null? No, that's not true, because class role 1 is null. So this is null does not equal null is false. True and false is false. And so now it should, if we've done everything right, it should jump out of the loop. And now it found a I is 1, but the length is 5, so that isn't true. And so we write the thing in the right spot. Now if we turn that off for a second, if we write, I should have chosen a smaller list. Let's just add another couple of names, foo, and we'll add the name bar, and we'll add the name, all these ones are succeeding, and we'll add the name Baz. Okay, so all three of those succeeded. And now if we look at our thing, we have a class role, all of them are full, so there are no null entries anymore. So now if we go back to our code and reinsert that breakpoint, now if we run this, we try to add a new name, add name Futplex. Computer scientists like weird words. What we can see is that, okay, we start at 0, we go around the loop, okay, we go to 1, we go to 2, we go to 3, we go to 4, we go to 5. Now, in this case, 5 is not less than the length of the list, and so the first test fails. And so once we've done that, we fail there. Now 5 is equal to the length of the list, so we did run out of entries, so we return false. And so we couldn't add that to we couldn't add Futplex to the list because there was no space to do it. So that's getting to a slightly more sophisticated example than anything you've seen before, but that's the kind of thing you'll be doing more of as we go. That's just sort of a first taste of that. If you didn't get all of that, we'll be doing more of that as we go. But I'm going to skip on. The other kind of collection that I want to look at is the HashMap. The HashMap is a collection that associates, so every array lists and arrays have all been indexed, and we've all said there's an index that it's an int, and there's a value at each index. A HashMap is different. A HashMap is a collection that associates two kinds of objects, a key and a value, and the key can be any time you want. So whereas an index, the key, in an array and in a list, the key is always a number as an index. In a hash map, the key can be anything you want. So an example of a hash map would be, you could use one to represent a dictionary where the key is the word you're looking up and the value is the meaning of that word. You could use one to represent a phone book where the key is the name of the person you're looking for and the value is their phone number, and so forth and so on. So a hash map is like an array, but rather than looking, or like an array or like a list, but rather than having things indexed by number, quiet please over there, please shut up. Rather than having things indexed by number, yes, you in the pink, tying your shoelaces, thank you. I should tell you about tying shoelaces later. Rather than indexing things by number, you index them by whatever you want. So a hash map is unordered. There's no strict ordering on a hash map. It's indexed by the key rather than by number, and it's variable size. So you can start with an empty hash map and make it grow or shrink. But like any other array, there can only be one value for each key. So if you have a single name, there can only be one phone number for that name, which might not be exactly what you want. But HashMap, the idea is that every key has one particular value. You can have the same value for many different keys. And so you could have like lots of people with the same phone number, but you can't have lots of phone numbers for one person, which is probably around the wrong way. But that just shows that you don't need to be using a hash map there. It's probably not the right thing. Like an array list, a hash map is part of the Java class library and so has to be imported. And so at the top of your code, you have to put import Java util hash map if you want to use it. The full documents are available on the web. You should look at this. I'm only going to explain a small fraction of what the hash map could do. And as we go, I'm going to be just using more and more classes that I'm going to expect you to look on the web for the documentation for that class. If it's in the Java API, I expect you to start trying to read these pages and understand what's going on. And like I said before, you don't need to memorize it because we will be giving you copies of the API whenever you're being tested and stuff. I don't remember all this stuff, so I don't expect you to memorize it all. But I do expect you to be able to read those pages and make sense of them. And some familiarity with them will actually help you do that. You don't want to be faced with them in the exam and never actually looked at one before and suddenly go, oh shit, I don't know how to actually use this documentation. So familiarize yourself with the documentation, but don't memorize it. So we declare one of these like we declare an array list. It's a generic, so it has type parameters. This one has two type parameters. So where before an array list just had the type of the things that are on the type of the values that were on the array, now we have two separate types. One is the type of the key, and the other is the type of the value. And so we can actually have completely different types. They can be strings and integers, they can be books and authors, they can be cars and gearboxes, they can be whatever we like. We can associate any two types together. But as with array lists, they can't be primitive types. So we can't have a hash map of ints or a hash map of little b booleans. If we want to use ints, we have to use the capital I integer, that wrapper class. Yes?
What if you just want to use floats or something?
You can't use lowercase floats, but you can use uppercase floats. There's a wrapper for floats as well as for ints. So when we do deal with floats, we haven't got that far. There's a wrapper for floats. There's a wrapper for booleans. All the primitive types have a wrapper for them. There's a wrapper for doubles, for longs, all of those things. So what we're going to do. So like the other things, there's a collection class. Then we have the key class is the first thing, and the second thing is the value class, and then we have the angle brackets like we've had before. So these ones I call them angle brackets. They're really just the greater than and less than symbol. Once again, we've now got 4 different kinds of brackets, right? We've got square brackets, which are what you use on arrays. We've got angle brackets, which are what you use on type parameters. We've got round brackets, which are what you use on methods for the parameters of a method. And we've got braces, the curly ones, which are what you use for bodies in your code. And you really got to make sure you know which one's which, because if you get them wrong, Java will hate you. So if nothing else, you get to learn your brackets in this subject. When we create a new hash map, if you look in the docs, there are several constructors, but like with the array list, we usually just use the empty constructor. And so we have an array list, an empty, so it looks like this. Hash map, we have to spell out the whole type, and in fact that should be integer, not int. And then the name of the variable, and then we can say new hash map, so we're using new to construct a new object. Hash map is the name of the collection, and then in the angle brackets, string and integer. So we have to, so it gets, one of the things about Java is that after a while it gets rather verbose. When you start doing things like this, the lines get long and in my opinion, needlessly cumbersome. But you're going to have to write code that looks like that. So you say, this variable is a hash map. It is a map from strings to integers. We're constructing a new one, and to construct a new one, we have to construct a new hash map, which maps from strings to integers. And initially, this is going to be empty, but it's going to be a map from strings to integers. Okay, how are we doing? Okay, we've got time. We're going to add things to this now, just to mix things up. The method for adding things to HashMap is called put, and so this put associates a value with a key. So this says find an entry for the key Malcolm and write the value 90. And so if there isn't one there, it creates a new key Malcolm and writes a new value 90 in there. If we put Claude 55, it says find the entry for Claude and write the value 55. If there isn't an entry there, it creates a new entry. So in this case, because our hash map was empty previously, we've created 2 new entries in there. We can also overwrite entries, and so if we now put Claude 65, we overwrite the value that was there, and so now Claude maps to 65. So we can, because every key has only one value, if we put several values in with the same key, we're overwriting the value for that key. We get things out using get, and it's similar to the way we get things from an array list, except that now we get them by whatever their key is. So if we get Malcolm, we get the value 90 back, and it returns 90. If we get a value that isn't in the map, we get back the value null. So because sim isn't in our map, there's no entry for sim, we will get back the value null. So this is one way for testing if something is in the map. We can ask whether we can get back the value null. This is a bit of a problem though. In particular, when we're dealing with these wrapper classes, integers and ints, we've got to remember that null is not a valid int. So if we do a piece of code that says that tries to get an integer back and assign it to an int, if that integer is null, we're going to have a problem when we assign an int to a null integer to an int. Let me show you what happens when we do that, just so you can see. I'm going to create a new thing in here. Let's just ignore that. Let's just do it in a little method here. Public void cause error Okay, so we're going to say HashMap string integer comma string comma integer map. Let's just call it map. Let's copy and paste this because I can't be bothered typing that again. Equals new. Quiet, please. So we're creating a new hash map there. So this hash map is empty. So now if we say int value equals map.get Malcolm. So what we're trying to do is get the value for Malcolm and assign it to this int variable. Okay, so now if we compile that, that'll compile okay. Oh no, it won't compile okay because I forgot to import HashMap. So let's go back and do that. I always forget this. Import java.util.hashmap. So you've always got to import it because it's in the class library. Okay, now compile. Good. Okay, so that compiles okay because from the compiler's point of view, there's nothing wrong with that code. It's valid code. The problem is it probably doesn't do what we want it to do. So if we now run, if we now create a new role, blah, 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 we don't really care what that value is because we just want to call this method here, cause error. Okay, so we get what's called a null pointer exception. And you'll probably see a lot of these in Java. This is somewhere where you've tried to do something with a null and it hasn't worked. So what you've got is that this value, map.getMalcolm, at the moment is going to return null. It's trying to turn null into an int and it can't do it. And so it tells you that there's a null pointer exception, which means that you got a null and we tried to do something with a null that didn't work. You're going to get a lot of those in your code from time to time. When you do something and you forget about the fact that a variable could be null, it'll give you a null pointer exception, and you're going to have to go spend some time trying to work it out. If we actually added a value here, if we said map.put Malcolm, 44, right, and we compile that, now the error will go away because we have to create a new role, create new role, blah, blah, blah. If we run that now, there will be no error. In fact, nothing happened because the program doesn't actually return anything. But that code works. So it's fine if we go to that window. If we actually get back a value, then it's automatically convert this 44, which is an integer, a capital I integer. It'll automatically convert that into an int without complaining. But if that value is null, then it tries to do that conversion. There is no value for an integer, for an int that's null, and so it'll complain and give you an error. So the correct thing to do. So like I said, if we try to get a field that exists, then it'll happily convert a capital I integer into a little I int. But if we try to get a field that doesn't exist, it'll give you a null pointer exception because it can't convert a null to an int. The solution is to always check before you try to do that conversion. So if we get back a mark in a capital I integer, which is an object, that capital I integer can be null. So we're allowed to store a null in a capital I one because it's an object. And we can, so that's fine, no conversion is happening. We can then actually test, say, is mark equal to null? And we'll do whatever's appropriate for if the mark is null. Otherwise, we'll do whatever we do in the non-null case. So this is something you'll do often in your code. You might have, if you get back a value and you don't know whether or not it's going to be null, you'll need to do some sort of conditional statement like this to check, is this value null? Did I actually get back a value or did I get back nothing? And if I got back nothing, then I have to do something appropriate. It might be printing an error. It might just be if Sim is not on our roll and we try to get her mark, we might just return a mark of 0. We might do anything. I don't know what the appropriate thing would do. It depends on your program. But you've got to handle this case because you don't want your program to crash, which is what it would do at the moment. And that would be bad. Your program should handle errors gracefully rather than just fall over and give you an error message. I know you probably use lots of programs which have fallen over and given you an error message, but that's not the best way to handle an error. You should actually do something more intelligent than that if you can. And in this case, you can check beforehand and make sure you avoid the error by testing for it. Once again, we can iterate. We cannot use the for each loop to directly iterate over a hash map, so that won't work. We can't. But what we can do is that there's a method on the hash map called keySet, which returns a set of all the keys that are being used. And we won't go into sets, but if you look up the documentation for sets, you can iterate over sets. And so we can do a for each loop over every key in the key set, and then do something with that key. In particular, so this value who would go through every key in our set. So it would go Morgan and Malcolm, then Morgan, then any other keys that are in our set. And then we could get the appropriate mark for that key, and then we could do whatever we want to do with that. So, for example, if we wanted, let's do something over in our code. Let's get rid of that one because we don't like it anymore. All right, so we're going to change our code now to be a hash. Have we got time? No, we don't have time. We could change this to be a hash map, but that would be more work than I can do in the amount of time available. So I'm just going to stop there. I think that's... So the last thing to say is that there are other methods in the class. You should really check out the documentation. A couple of the useful ones. It has like an array list, it has a size to tell you how many things are there. You can check, you can remove things, you can check if they're on there. Do go read the documentation to find out what it is.